Hi, and welcome to session 1 of the grade 3 course. We're starting with multiplying decimals. You can see I've already got my Chinese grid all set out ready to use. So this is what I'm going to use and demonstrate as I go. If you've got an alternative method that you use, that is absolutely fine, of course. We just want you to have methods that you are able to get the correct answers using. Okay, so in the grade 2 course, I talked a lot about this method and we used it throughout. And for that reason, I'm going to continue using this particular method when it comes to our multiplication. Okay, so let's get stuck straight in and have a little look at a question that involves decimals. Okay, so if I was to have the question 0.5 times 7, okay, what I'm actually going to do, and I always do this, it doesn't matter what the question looks like, I will always do this, is I'm going to ignore it. I'm going to pretend like the decimal isn't in there, even there, and I'm just going to write 5 times 7. And then I'm just going to do my normal times tables. 5 7s are 35. So we'll write that down. Then I start to consider the differences between the two questions. So the 7 is exactly the same in both questions. It's actually here where there is a slight difference. Okay, this number has a decimal point in front of the 5, whereas this number has it on the end. Remember that all integers stop at the decimal point, so they've got that invisible decimal point on the end. So if I'm going to make them the same, I would technically need to take this, move the decimal point here, and the process would have been to divide by 10. The maths that's happening is to divide by 10. Now I've got the matching in the question. I've just got to keep the balance and do a divide by 10 on the answer. And I can see a decimal point moving into that spot there. And I've got my answer 3.5. All right, let's see that again. So we'll do another question. Let's do a similar looking one. Let's do 0.5 times 0.7 this time. So I'm ignoring the decimals and using just the digits that I've got given to me. And I know using my times tables that 5 7s are 35. And then I consider the differences in the question. To get the 5 to look like the 5 in the question, I'd need to get a decimal point here, which would involve dividing by 10. And I need to do the same with the 7. I need to get the decimal point there, which involves dividing by 10 again. And because divide by 10 has happened twice on this side, it's going to happen twice on this side. So I am going to divide by 10 and divide by 10 again. And I'm going to stick my decimal point in there. So my final answer is 0.35. Now, I want to do things as efficiently and as quickly as I can. So rather than writing out that I'm dividing by 10 or I'm dividing by 100 or 1,000 or whatever it is I'm going to be dividing by, I am going to just count the arrows. And that way it will make it a lot easier for me to just get the decimal point in the right place without having to think too hard about it. So let's do 0.7 times 0.12. Ignoring the decimals gives me 7 times 12, which is 84, just normal times tables for that particular question. And then I'm going to get those decimals where they should live. Okay, that decimal should be here. That's one arrow. I could label it 1 if I wanted to. Here, I've got to move once and I've got to move twice. So that's 2 movements to get that decimal in the right place, technically dividing by 100. In total, I've got 3 arrows, or I've got a total of 3 movements to get the question to look like the question we were given in the first place, which means I am going to be coming in 3 places 3 arrows in my answer of 84. So I'm going to go 1, 2, and then I'm going to go again. And my decimal point is quite a way over. It's kind of landed in my equals, hasn't it? It's quite a way over from the 8. So I call these like buckets. Don't know why, I just do. I call them like buckets, and I've got an empty one. And if I've got an empty bucket, I've got to fill it with a 0. So what I'm going to do is, just so I don't start writing over loads of stuff, let's just move that across a little bit. So I've done my arrow, my decimal point is landed there. I have an empty bucket here. Yeah. So I'm going to fill that with a 0. I'm going to do it in blue. Let me get the blue. There it is. And then I've got the decimal point. I don't want that decimal point to float away. So I sandwich it with another 0. I don't want to put a number in there. And there's my final answer, 0.084. 3 movements to get that decimal in the right place. So the main idea is that we ignore the decimal, use the methods that we have for just normal multiplication, and then boom, 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 put it back in at the end. So let us do a question for you guys now. So what I want you to do is pause and press play when you have had a go at that question. Okay, so I'm going to write it out without decimals. So all I need to do is double that number, which is 96. I've then got to make the question, make this look like the question. So in 1, and I've got to go in 1 to get that decimal point there. So that's in 2 places, putting it there. So my final answer is 0.96. Okay, so if you got that right, fabulous. Let's do another one. Just checking in, making sure we feel happy. So 0.4 times 8. Pause and hit play when you are ready to have a look at the answer. Okay, so 4 times 8 is 32. I've got to come in 1 place to get the decimal point where it needs to be. Don't need to do anything with the 8. So it's just a movement of 1 this side. So it's a movement of 1 that side. So my answer is 3.2. All right, let's do one more, and then we will look at a slightly bigger question. Let's do 0.9 times 0.03. So hit that pause button and press play when you're ready. Okay, so 9 times 3 is equal to 27. Okay, we've got 1 movement, and then we've got the 3. Then we've got to go around a 0 that we can't even really see to get our point there. So there's that 0. So that was 2 movements. That gives me a total of 3 movements. So 1, 2, 3. There it is. Fill in that 0. It's 0.027. Okay. You could, if you wanted to, literally just count the digits past the points. I've got 1 there. I've got 2 there. 1, 2, 3. I'm in 3 places. So you don't have to draw arrows even. You could literally count digits and it would still work. I like the arrows though. It helps me see what I'm doing and it keeps me focused on the maths that's happening, if you like. All right, so moving on. We're going to do questions that are outside our times tables. So for example, we could do 4.81 times 7. I will rewrite that question to be 481 times 7. And of course, I don't know my 7s all the way up into the hundreds. I know them up to 7 times 12, and that's about it. So this is where we would start to use our long multiplication methods. So I'm just going to copy that so that I can keep that and paste to use. So I'm going to use the Chinese grid. As I say, that is the one that we were using in the grade 2 video. It's always a 3 by 3. Then it's just ready to go. I'm not having to think about changing it for any reason. Multiplying in 0, 7, 8 sevens are 56, 4 sevens are 28. And then I'm adding down through my diagonals to get my final answer. So 7 drops out there, 6, 8 plus 5 is 13, carry the 1, and then I've got 2 plus that 1 is 3. So my answer is 3, 3, 6, 7. I'm trying to squash everything in, aren't I? Let's try and just get a bit of space. That's better. Now I'm just going to do my counting, aren't I? So 7 is the same. I've got to go in 2 places. So I'm going in 2 places and I've got my 33.67 as my final answer. So it's really just a counting exercise on top of using a method that you already have and you're already confident with. Just nice and simple, which is what we want. We don't want to make things hard. All right, let's have a look at another question. Might as well use this. Now I've copied it. Get that in there. Okay, let's do minus 6.8 times 23. There's a lot going on in that particular question. I'm actually going to ignore 2 things. I'm going to ignore the decimal because that's what I've learned today. Don't bother with the decimal till the end. So I'm going to ignore that, but I'm also going to ignore the negative. I'm not going to worry that there's a negative in this question. I'm just going to do what I know. Okay. So 68 times 23. I don't know how to do that in my head. Going to use my grid. Oops, that's not right. That's 68, 23. And then start multiplying in. So 8 2s are 16, 6 2s are 12, 8 3s are 24, and 3 6s are 18. 4, 8, 10, 16, carry that 1, 1, 2, 3, 4, 5, and we've got 1. So we've got 1, 5, 6, 4. Now let's get that decimal in the right place. So I need to come in 1 on here. Don't do anything with the 23. So we're coming in 1. So we've now got 156.4, so 156.4. Now the last thing that I'm going to do is consider that negative, okay? So if I've got a multiplication question with 1 negative in the question, then I've got 1 in the answer. And that's how I remember it, okay? 1 in the question, 1 in the answer. So I'm just going to pop a negative in front of the answer that I've got. And that's how you could also bring in a negative if you needed to. Okay. I just thought I'd share that just in case. So you are going to practice this. I don't think I've put any negatives in, but you are very welcome to change the question and put a negative or 2 in and in practice around that. We will see that kind of thing as the course progresses. So we're constantly recalling our methods and making sure that we haven't forgotten how to do things by repeating them at the beginning of every session. And then obviously I build some challenge in as we go, so that negative isn't going to disappear forever. All right, so these are your questions. Let's get that down a little bit so you can see them all. There we go, perfect. Obviously, I want you to just practice. Practice is what makes perfect. So I've given you a variety of questions there, and you can just check on a calculator. If it's, you will know if you are completely lost on the method, or if an answer is wrong. Let me start that again. If an answer is wrong, you will know if it's method, because you'll be floundering around thinking, I don't really know what I'm doing. Whereas if you're going for it really confidently, then you know that your method is probably secure. And if a wrong answer pops up, it's probably just a times table error. Just one little calculation went wrong somewhere along the way. And that's very normal. Human error is what we call that. Okay, it's not a maths error in the sense that you don't understand what you're doing. If you do feel a little like you haven't seen enough, then you can always go back, rewatch those examples, go back through things carefully so that you can feel a little bit more confident when you get started on these. All right, so good luck with those questions, and I will see you next session for division.